All right, guys, sorry to change this up and not be here. Hopefully you've already copied all of this down. So today, the last part of this chapter is we are making sure that you understand how to know the difference in these types of equations. So first type here is linear, of course, y equals mx plus b. The exponent on the x is always a 1. It's going to make a line. And on your tables, there is going to be a constant difference. So you're either going to be adding the same number or subtracting, which is technically adding a negative. So the difference of the y values is constant. First thing, notice that all of the difference of the x values is all 1 on all of these. So that's why we can ignore that and just focus on the y's. So your delta y, your change in y is 2 on this one and -2 on these. So that is a common or constant difference. So linear, going to make a line. For exponential, you're going to have an exponent that is a variable. Your graph is going to look something like this. It could be reflected down here. This is growth. It could be decay and be this way over here or flipped or reflected down there. On this, you are going to look for a constant ratio. So you are either multiplying or dividing by the same number. Technically, dividing by 2 is the same as multiplying by 1/2. So up here, you are adding or subtracting for linear. For exponential, you're multiplying. And think about this. This does get very large very quickly, so that's very exponential. The third type would be our quadratic that we've just spent the last couple of chapters. It is going to have a 2 or a squared on the x, and that means it's a degree of 2. The graph is going to be a parabola. Now, this is part that we have not focused on quite as much yet, so tune in here. When you look at these, I'm going to start with this one over here. You might notice how this is kind of going up and then back down. That might clue you in to kind of start thinking about what this graph might look like, and you might say, oh, it's going to be a parabola. Well, it might be a parabola, but it could also be the absolute value that we'll talk about down here. And then if you look at this one, we know it's going up, but I didn't show you the other side of the parabola, so that makes this different. As you look, you might say, oh, it's adding 4 and then nope. Okay, well, it's multiplying by 5. Nope. So you're like, what? It's nothing. There's just no pattern. Check this out. If you look at this and you think there's no pattern, you might need to go to the second difference. So from here to here, we're adding 4, adding 12, adding 20, and adding 28. But the second difference from 4 to 12, 12 to 20, or 20 to 28 is adding 8. So that's what's going to be constant in a quadratic. If you look, the same thing is going over here. You think there's not really a pattern, but there is. Okay, down here with the absolute value functions, your x, your variable x, is going to be inside of the absolute value. It is going to be a V-shaped graph versus a U. And again, like this one, you might say, oh, maybe this is quadratic. That could be a parabola, because you can kind of see that it's going down and then back up. But if you look at it, it's a constant rate of change. The legs of this graph have a slope. So that's what you're seeing here. And same here, there's a constant rate, but it might be both positive and negative because of your two sides or legs of that graph. So that's the difference between equations, graphs, and tables of all of these. So go ahead and flip that over. You're going to determine whether these equations are linear, exponential, absolute value, or quadratic. So use those notes that we just did on the last side. I'm going to pause this video and then come back with answers on that. And I also want you to look at these graphs. So we're going to do 1 through 12. I'm going to pause this, give you a few minutes to do that, and then we'll start this back up, show you the answers so that you guys can help each other out, ask questions as needed. Okay, so hopefully you got all of these. I think these are the simpler kind are from the equations or from the graphs. This one I want to take a minute. It said which of these, and honestly, reading the directions tipped me off. I almost wrote linear myself, but it says if none apply, explain. And I was like, why would these be none? So, or whether this is a linear, exponential, absolute value, or quadratic function. This one is not a function. If you remember, vertical line, not a function. It has multiple outputs for, like in this case, an input of 2 gives you all these multiple outputs. This is the only line that is not a function. So then go on down to here. Let's look at these. So these 6, plot the points and then determine whether they appear to represent linear, exponential, absolute value, or quadratic. And then same here, look at these. Actually, let's just go ahead and have you pause and finish this page, and then we'll unpause the video and show you some answers and talk through it. All right, and last thing, so this table is going to be linear because every time we are subtracting 3, that's a constant rate of change. These are a little harder to see. You might have kind of started to see this shape in looking at this, but it's going to be a quadratic. And so the second difference is constant. Absolute value, when it's has a constant rate of change, but yet it's positives and negatives. And then exponential, this looks like it was dividing by 2, which is the same thing as multiplying by 1/2. So that's going to be exponential. Just kind of think about what happens when you throw a ball into the air. It's going to come down. That's going to be quadratic. Your friend can type 85 words per minute. That's a constant rate, so linear. And then lastly, if something doubles every year, that's times 2. So that is exponential. Do your work, and I will see you tomorrow. Thanks.